I will try to give a kind of background to what I want to start today. So let me just start what I'll be talking about. So the first topic we are going to be talking about today is introduction to machine learning. And yeah, I'm not sure the organizer have shared with you the course content. I have shared the course content that I want to follow through. This is the most important foundational topics that you will need if you are interested in machine learning. You can always get this slide later that you will need if you are interested in machine learning. We'll try and build model, implement them, talk about the mathematical aspect of them, and share ideas along the way. So I intend to cover some topics. The first one I'm going to do today is to give a background introduction to machine learning. Then subsequently, because I know that Python is important, I would have just skipped it. Yeah, but I think Python is very important. So I'll try to, refresh our brain and our mind on some of the, Python topics that are needed to build basic machine learning model. So in between these, lectures, I will try to get your hands dirty. I have two approaches that I want to use for that. You can see this link is my blog. For every topic that we do on a daily, on weekly basis, I will have a blog that will explain the topic. For example, this particular topic, I've already written a blog that you can read on your own to understand all the concepts that I'm going to explain in case you need more follow-up. So today, we will start with focusing on the first concept of our scheme, which is machine learning. So in that aspect of machine learning, we'll be delving into the building block, the three building block of machine learning. We're going to be talking about the concept of perceptron and the algorithm that build up perceptron. We're going to be talking about supervised, the theoretical understanding of supervised, unsupervised, and reinforcement learning. And we're going to be talking about exploring where is machine learning used. So I'll give a brief analogy on how I would like to express machine learning. Let's say, for instance, that I am part of a committee in a school that are trying to get students admitted to a school. And we are told that I want you to be with me. Okay, we are looking at two things to determine if a student is accepted or rejected. And those two things are, we have their test score, their grade, and their test score. These are the two criteria that we will use to check if this person is accepted or not. You see these two criteria, I'll call it, let me still use that. I don't want to start using technical word. You see these two criteria that we are looking at, they will be the determinant or the determining factor to help me as an examiner to decide if I'm going to take that individual in or reject the individual. With that kind of mindset, which we are familiar with, let me now start speaking technically now. These two parameters that we are talking about that will determine if I'm going to take students in or not is called the input feature, or it is called the input feature, or we can just call it S, The determining factor that will determine if me as an examiner is going to accept a student or reject a student, it is this S. We are all familiar with S in mathematics. But in machine learning terms, we call it input. It is the input feature, which is the S. These two parameters, they will determine if I will accept the person or not. But that decision of acceptance or rejection can be maybe if let me go down. If I accept or reject, I will call it input feature. But the decision of acceptance or rejecting can also be done automatically by a machine. I, as an individual, can decide that, okay, maybe if an individual scored 5 in a test and also scored 5 in grade, then averagely, I will say that the person 5 plus 5, that is 10, divided by 2, that's going to be 5. So it means that if the average is 5, then I will accept that person, the average of the 2 mark. This particular analogy that I've made is what machine does to make a decision. So the ability of a machine to do an autonomous, like, I am not the one giving, autonomous means, what is autonomous now? Another word for autonomous.
Independent.
Independence. Okay, a machine can also make the decision that, okay, I gave you this input feature. I have explained what an input feature is. So this is the score of a student, the score and the grade. I gave you the 2. So machine, make a decision whether you will accept that person or you won't accept the person. I've told you that if I'm going to make that decision, I'll find the average, and the average, if it score 5, then maybe I will accept the person. That's the autonomous decision, or the ability for machine to independently make that decision, is called machine learning. Are we together? Is that clear? So machine learning is the ability of a machine to do the job of a human being without being told explicitly. When you say you are being told explicitly, it's the explicit instruction given to machine is done by the programmers. For instance, your mobile phone, your laptop, there is what we call software that work on them. Traditionally, programmers, they are the ones that give the instruction that must be followed by machine. When you have a program, WhatsApp, for instance, it is a chat messaging application. Everything that WhatsApp is done, it is explicitly written by a programmer, one by one. But in machine learning, the programmer will not explicitly tell the computer what to do. It is the machine that will do it autonomously. That is just the difference. So machine learning is the ability of machine to make decision independently. So I would like to move on. So let's start getting into the details of machine learning now. We have said that machine learning is the ability to make decision. I said that if I'm to make that decision, I'm going to give it some input, which I call input feature, and I denoted it with S. Don't forget that if I have input, then I have to map it to something, which is going to be the output, which is our Y. In mathematics, we like using X and Y. So if I have an input, which is going to be used or processed by a human being or a computer, then I must get an output. Most of the time, that output in our mathematics term, we use Y to denote it. Okay. So in that case, if I have an input which I call input feature, then the output, we can call it response variable. We can call it response variable, or we call it output feature, or we call it output. We also have some other names for them, but let me list all of them. You can also call this one independent variable. I will tell you why is this independent variable, why it's called that. I want to give you all the terminology that they are used. You can write it down if you want to. I want to give you all the terminology that I use. This one is also called independent variable, and this one is called dependent variable. So before we start moving into the mathematics and you are lost in the process, I don't want you to get lost. I want it to be as simple as possible. So if anything is not clear as I'm gesticulating and speaking, please let me know. So these are all the terminologies that are used for what you give the computer, which are called the input feature, or we call it the independent variable. Then the results that will be produced after it has done its operation, we call it the response variable or the output, or we call it the dependent variable. So let's now talk about this style. I mean, this guy. There's what we call perceptron. Perceptron is a representation. I would say is a model. It's a representation of what will happen between the input feature and the output feature. Let me try to rephrase that. The action of giving computer something to work with and give me output. That action can be represented with an equation, with a model, mathematical model. The mathematical model that is used in representing that action is called perceptron. Perceptron is the equation that will represent what I'm talking about here. Technically or in-depthly, we can read that, you can read that in blog, but perceptron is the first way to help to mimic that the scientists use to mimic the brain of human being, simulate how the neurons in our brain work. Neurons in our brain, they connect themselves and they pass, the input from one neuron, it gets its output, and that output is being passed as input to another neuron. That's what I'm trying to do there, but I'm not so good in that. So let me now go to the mathematical representation of perceptron. So I said that perceptron represents this equation I'm talking about. Sorry. So if I want my machine to take input and process that input to give me output, I will have to use a model, a mathematical model. And that mathematical model is a model we are all familiar with, which I will represent with this. Y equals to MS plus B. For instance, let's assume that we have our graph. If you have plotted quadratic graph or linear graph before, we normally have a set of inputs in the x-axis here. The x is going to have some values here. The y is going to have some value here. This is y. This is s. And of course, for instance, now let me say students have score grades to be 6, score and grade to be 6 and 7. Let's say this is 6 for x. This is s. Don't forget, this is Cartesian, representation. I'm speaking some mathematics term. If you don't get it, let me just know. Cartesian, representation of number. They call it Cartesian. And the meaning of that is this diagram that I've drawn. So let's say the student score, I've told you that two things represent student score. The score and the grade, okay? If I want to represent the student score on this Cartesian plane, the s, let's say is 6, and the grade, let's say is 7. Of course, I'm going to have it represented with this. That's just what the machine does. The machine will represent the two inputs you are giving it to have an output here. And this straight line is represented with this equation, which we call equation of straight line. For any machine learning that you build, this equation is the fundamental of that machine learning, and it is what we call the perceptron. Are we together? Yeah.
I remember this from secondary school drawing of graph. But then we use scale. So the scale does not apply here, or it doesn't.
No, I'm not drawing it to scale. I'm just illustrating. Of course, scale is used when you are drawing the real graph.
I don't want to be lost. So there's no scaling here.
I'm not scaling. I'm just trying to give illustration of what I'm doing.
Right.
So I want you to remember one particular formula clearly. I'm sure that some of us would have seen it in our secondary school and the rest of them. I'm going to interpret what they have meant. The y, I've already told you what y is. The s, it is this s that will determine the y. That is why we call s the independent. It is independent of this, because these are the inputs that you put to the graph or to the machine. It is called the independent variable, or we call it the input variable or the input feature. Okay. Then look at this guy. This one is called slope, but I don't want to go into that now. Let's just leave it as slope. It is changing while we're changing it. Don't let us start disturbing ourselves with that. But what we really need in our machine learning is this one, which is the output. But the output will not be gotten until you are given this and this. If you have the test score of 7 and the grade of 6, This one, they call it bias. But in mathematics, we can call it constant for now. But in machine learning, they call it bias. I will explain what it does. Then when you give it this input, of course, you can calculate your output by putting it here, your S, your C, and you get your Y. Of course, they still do some other things that I will not want to go into for now. But just remember the formula. So when a machine is making a decision and is giving all the input, the decision can be bounded in such a way that if the value is gotten after it has calculated it, if it is greater than or equal to 0, we can say that that value is positive, right? If it is greater than or equal to 0, from 0 upward, it can be 0 or upward. That value is positive. So if it is positive, then we can say that that child should be accepted. Do you understand what I'm saying? Or after the calculation has been made, then the value is 0. Maybe the student got low mark in some of them. Then at the end of the day, it's going to be negative. So if it is negative, it's going to be rejected. So the decision will be made not by magic, but by calculation. Perceptron is the building block of machine learning. It's the algorithm that is at the backbone of machine learning. So let's now speak, in a more general terms now. I have given an example of what the equation should look like. But in a more general terms, when you are building a machine learning model, we normally have more than one input feature. For instance, if I want to predict the price of a house, I can say the location of the house, what year the house was built, the color of the house. I'm not sure color is going to be very useful here. In a machine learning model, just S, most of the time, they are more than 2. And that is what is represented with this. We can have input feature from 1, 2, up to Sn. Mathematics like to use all these things to represent unknown. Then, of course, I talked about constants. I call this B, I change it to constant here. Yeah, in mathematics formula, they use C. It's the same thing with machine learning. We call it bias. Bias is a constant. And don't let us go into that. But let us just know that you can relate it with the mathematics and it is just constant. Because I know mathematics can be somehow scary. No, we have a general formula here. We have a general formula here, which is representing more than one of these. We have WS. Now, our formula has changed from Y equals to Fs. Now, my M here is now represented with what? WS. Instead of writing M in mathematics, we have WS plus, instead of my C, then we are going to have B. Your B is the bias, which is the same thing as the constant. Your W is the same thing as your L, and that is called the slope. But in machine learning, we call it weight. Let me explain what weight does. The weight or the slope, it determines how strong or the value that is attached to a particular independent variable. Let me come to it. I said that when we want to predict or we want to measure the price of a house, for instance, we are going to consider the location of the house as an input feature. We can also be given what? The number of stories in the house, the number of story building in the house. This is not another input feature. What other input feature can we talk about? We are talking of house, the price of the house. If you want to build a model for a house or any other thing, let's look.
Number of rooms.
Number of rooms in the house. We are mentioning all these things. They can be input that I will put to the computer. But we all know that it is not all the inputs that should have the same power. One of them will be more relevant than the other. And that is what that weight does when you are building a machine learning model. The machine learning model is going to give one input feature more energy, more weight, more relevance than another model, than another feature. Do we understand? I want to get a feedback.
I think you should pick that thing.
Okay, let me just write it down. Let's assume that I want to build a model that gives me the price of a house. Then I have different features. I have different features, like input feature. Let's say we have what we call location. What is that thing?
Type.
Number of rooms.
Yeah.
Rooms.
It's bedroom, you remember among rooms.
What are that things that we can put in the computer to help it decide?
Area of house.
Location.
Location.
The location is the type of house. What other thing?
Maybe just to the type.
Decoration.
Yeah, decoration, so as colors, or let's call it decoration. Design.
Design. Okay.
Design.
So let's stop here, for instance. So these are the features of this house, and they are the things that you will pass to a computer. They are the S that you will use. What I'm saying about this W, which is from this, it is called the weight. And this weight, you can see that it is attached with this S. It is being multiplied with the S. The weight represents the relevance of each of these. How relevance is going to determine how relevant each of these AP feature will be. For instance, in the case of price of a house, the weight of location can be more. Let's say it is 10, just assuming. It can be 10. The weight of room can also be very relevant. Let's say it is also 9, for instance. I'm just assuming. The type of the house might not be that much. Let's say it is 2, for instance. The design of the house, maybe that one too will be relevant. Let's say it is 5, for instance. You see this figure is going to be multiplied with each value of the independent variable. That is, there will be a value for location on its own. This value that I've written here, they are W's. I'm just assuming. Then that will be multiplied, for example, we can say 10. Let's say the location is maybe 2 degree, whatever, is 2, plus the constant. There will be a constant, which I will not delve into now. This one is going to give me the weight or the output of location. Then it will do the same thing for room. That's 9. And this one, maybe the room is 4 or 5, for instance. 5 plus 10, and so on and so forth.
Before we continue, what represents the constant here, 10, for this example of house?
Constant is just a value that will be constant, as it is called.
Yes, but then what can we say represents that constant with
In
this
this
example?
particular situation.
Will it be the, for example, would it be the country?
No,
Let's say in this country, what could not be that constant?
If we are building a model, the constant is normally given by, most of the time we don't single-handedly put the constant in our model.
Okay.
We don't.
Okay.
If I'm building a model now, I'm not going to factor in the constant.
All right.
The constant is called bias. We call it bias because it's something that's, maybe our own subconscious bias when we are building a model. If I want to build something now, I have my own subconscious bias as a human being. So the bias is just, or the constant, but you call it bias in machine learning. The bias is just to factor in the bias that will come from a machine learning, an engineer that is building the model. There will be some bias that might affect his model building. It's just to factor that in. We don't explicitly represent constant or bias in our machine learning model.
It's always there. We don't have
We don't have to bother ourselves. If you want to write a linear regression now, what you need most is the weight and the input feature. We are not interested. We are not going to manufacture a value for the bias. We don't do that.
So to not also mix this together. The weight here is also
The slope.
the slope, and then it's also like coefficient.
It's coefficient, of course.
Okay.
In mathematics terms, they call it coefficient, of course. If a value, something before something, call it coefficient. Most of the time, we use coefficient if you have something like this in mathematics. So the coefficient of x here is 2. Most time, if you use coefficient in mathematics, it is always a value or a constant that is at the front of a variable. But these two, they are both variable. So we will not necessarily call W coefficient here because they are both variable. We don't attach value to them yet.
Okay, I think some of us are also familiar with constants being an intercept.
Yeah, the intercept, of course.
Mathematically,
It is the intercept. Yeah, and even I'm speaking in the mathematics term now, and I draw this graph. So the value here is the intercept. But in machine learning, I'm going to machine learning. So in machine learning, most of the time, we don't really, identify or explicitly say intercept or bias. We don't have a value for it, but it's there.
Okay, so the model generates it automatically.
The model will generate it automatically.
So we should not be bothered about it.
We don't bother about it when we are building model. But in mathematical sense, of course, you can know it as an intercept.
Makes sense.
I hope I'm not confusing you too much.
It makes sense.
I want you to follow through as we go through the courses so that at least you will be comfortable when we start dealing with the more technical aspect of it, so that you won't be discouraged, I think. So in general terms, the equation of perceptron in general terms is just like the equation of straight line that we are familiar with in our mathematics. Y is the same thing as Y here. N has just changed to W. S is still the same thing as S. Then my C is my B. just know that as the equation of perceptron. And that is all we need to know about the equation of perceptron. So I would like to move forward, unless there is any question or clarification before I move forward.
So mathematically, if the model calculates like behind the scene, so the machine is going to calculate each one of them and do the summation of it to get the output.
Yeah, the output is going to be the Y. Yeah, okay. I did not, represent it with this. So when we have multiple S, S1, S2, S3, then of course we will have to sum it in terms of the number of S. This one is I starting from 1 up to N. The N represents the number of input feature that you have in the data set. If the mathematics is boring to you, I don't need to say this. I don't want you to be confused. So this particular thing is just that we are doing the summation I times based on the number of features, input feature you have in your data set. Then this is WI, this is SI, this is what the model will actually do, plus B. You can see that B does not take I here. It is just a constant. It doesn't change. It's a single value. That's why you will be able to understand B from this guy better, from the first equation of straight line initially. So, can I move on? So
two things changes. Two things. That's the W and the X. It's always change.
The S, you'll be the one to give the S, because the S is your input feature. Okay. But W, it is the model that will automatically learn the W itself. That W is called the weight, is the power of the machine learning. It's going to learn that W based on the input feature. How relevant are they? It's the one to learn the W automatically itself. You are not the one to give W to it. And that is why it's machine learning. It is the W that will determine the decision it's going to make. So when you have the input feature to be location, rooms, types, so the machine will learn that which one has power, that's the weight, which one has big power. Then it's going to use that to determine which one, what's the price of the house, for instance.
One question. So that means the W now, like if a model generates something out using those parameters, and like maybe the person, like they now told the model, okay, like something like reinforcement learning, they now told the model is wrong, so it's going to give the W a more higher value to generate the correct one.
I think I should say something. The W, most times, if I'm building a model, I can give it initial value. Most of the time, if you want to give it initial value, we give 0. You give a first value for it, which is 0 most times. But after that 0, the model is going to automatically learn or give it a random value sometimes. But that one is just outside the scope. But if you want to start training the model initially, we can see that when we start implementing, you can give W a 0 value, for instance, just to initiate the training of the model. But it's the model that we have to learn doing back propagation. Oh, don't let me go there. Doing some stuff and try to readjust. Okay, which one will I give more weight compared to another? So your question, I don't think I've gotten to your question. Have I answered your question? Just re-ask again. Yeah.
So the W is assigned during the training. So, but my own question is, like now, the W is not constant. It changes according to the machine is learning more information about the X that is being given to it. So I'm not saying like now, if the W, like the Y, the output, so the model give a wrong output, like maybe in reinforcement learning. So we're now like, oh, this thing is wrong. So an input another right value to it. So the model is going to.
No.
I ask ChatGPT a question. He said he doesn't know it. And I'm going to look for the answer and tell ChatGPT, oh, this is the meaning of this thing. So the next time I now ask again, he now tell me the answer.
The answer that you gave it.
The answer I gave it.
What you are doing?
So I'm not saying like automatically, like it doesn't, is it related to the W? It says that maybe the W, it doesn't assign a high value to it. So automatically after the model now know it, so you now give it a new higher value.
what you have done to ChatGPT case now is what we call prompt engineering or fine-tuning.
They should pay me well.
You have taught ChatGPT what ChatGPT is trained on some data set. Maybe it doesn't have that, information in its trained data set. But what I'm talking about here is not at the level of ChatGPT. What I'm talking about here is that when I'm building a model, for instance, let's say we know that we are dealing with supervised learning. Let me give you an example of supervised learning. I know that the price of this pen is 10. The price of the pen is 10. Then I build a model, a machine learning model. To predict the price, I will pass to it some correct information that when you see this type of pen, the output Y is 10. That's supervised learning. I'll give you some correct output. So let me now say after I've finished training it, the process of training it is that, okay, I have shown ChatGPT the mapping. This is S, and this is your Y. Anytime you see this type of S, you get this type of Y. Anytime you see this type of pen, the price is always 10. Then let me now say, and I bring another data set that the model has not seen before. Okay, which is like the type that I used to train it, but I did not, the model have not seen it before. I did not train it on that data set. Then I now pass it to it again. I pass this into, I want to make inference. I want to see if the model really, if it has learned from the data. If it has learned, then I will say, I will not, in passing the new data set to it, I will not give it Y label again. If I'm, do you understand what I'm saying? I'm going too technical. If I'm going too technical, it doesn't matter. We will get there subsequently. I don't want to start dwelling into what you don't necessarily need for now. But the W is the power of a machine learning actually. It is always learned automatically and it is adjusted by the machine itself as it learns. Of course, machine also use a technique, a mathematics technique called calculus, or we call it differential calculus. But I would not like to go into that now because we don't need it now. For a machine to really adjust its learning so that it will be very closer to the actual or the correct answer, it does what we call back propagation. So let's deal with some theoretical understanding of supervised learning. We have said that we'll be talking about types of machine learning. Then we have mentioned what we call the supervised learning. The supervised learning is the type of machine learning that you have some data set that you give to the machine, they will already contain the correct answer. Don't forget that we are dealing with our S and Y mapping. Your S, they are the inputs that you give to your machine to give Y. But when you are talking of supervised learning, you have already given your machine the correct answer. So you want the machine to learn the relationship between that S and the Y. Do you understand what I'm saying about supervised learning? In supervised learning, your data set will have contained, okay, the price of this type of house is 10. The price of this type of house, the house that have this feature, location, all the features that we have mentioned, okay? Then the price, that is the output, that is your Y, and that is the right answer. When you're dealing with supervised learning, you have given it the input features and you have given it the response variable, which is your Y. And that is the way you train this type of machine learning. In supervised learning, there is always a training data set that will contain both the S and the Y. For instance, if I want to train a model that will recognize the picture of a cat, for instance now, then I will get people that will label the name of a particular picture. Okay, this picture, now if you see it, you are going to write cat. If you see another one, you write dog. You know, that naming you give to it is like, if I'm training it, I will now pass to that machine a picture containing a name. Do you understand? If you are not understanding, let me get feedback. You understand what supervised learning is? So machine will be giving both the input and the correct output. in a very simple term. So in supervised learning, we have two types of problem sets that we use it to tackle. Anytime you are talking of supervised learning, we have two major problem sets that we will use this supervised learning to tackle, and they are classification problem and regression problem. In classification problem, it means that you are classifying. In classification problem, you are trying to classify basically. Let me see. Identify category or discrete relationship. In classification problem, the outputs you want to get, they are definite. I will use another English. If I want to build a problem, or I want to use machine learning to solve a problem, and the output that I want to get, I know the number of outputs I want to get. Let's say, for instance, now, I want to predict maybe it is a boy or a girl. The output is 2. They are definite. They are discrete. Those are the English words. As in, I know the number. Anytime you want to deal with a problem that you know the number of outputs you want to get, then you can use classification problem. Anytime you want to get an output that is definite, we call it classification problem. Will you understand classification problem? I know the number of output that I want. I have some chunk of emails, okay? And I have labeled some email. You know, when you're dealing with supervised learning, you have to give the correct answer. This email, because of this thing, because it contains some funny address, it is a spam email. The label, I labeled the email as spam. And I said, this email is from UFCPO. It does not contain unwarranted address. This is a good email. It's on spam, so to speak. So you give it a label, as in label. We know what a label is. So that label, I know that I want to get either it is spam or not spam. Either it is spam or not spam. If I'm getting two outputs, then this is called a classification problem. Of course, classification problem also has its own types. And I think I'm going to be discussing 2 here, or 1, I don't know. We have binary classification. When we want to get an output that is just 2, we call it binary classification. Of course, we'll delve into that later when we are dealing with the technical aspect. Then we have the multi-class classification. That one when you are interested in more than 2 outputs. If I want to deal with classification that will give me picture of different animals now, dog, cat, what again? Monkey. If it is more than 2, we call it multi-class classification. So if you want to implement classification problem, we will use this type of algorithm to implement them. We have what we call logistic regression. I'm going to delve into them later when we are dealing with each of the topics. But for now, just know that, just get the clarification of machine learning and their type clearly. We have what we call logistic regression. We have decision tree. We have separate measurement. God willing, we will implement each of them with the code and the data set. God willing. God willing. So we have regression. Regression is not used for categorical output. When you say categorical, I've used some English word. I said categorical. I said discrete. I said definite. It means the same thing. It means that you know the number of particular outputs you want. If it is 2, if it is 3, that's classification problem. But when you're talking of problem, that the outputs you want to get, they are not definite. It can be between 1 and 2. When you say something is between 1 and 2 in number line, in mathematics, is it permanent? It appears so. If I say a number is between 1 and 2, for instance, 1 and 2. In mathematics, you can have 1.1, 1.2, and so on. Okay. And so on. Now, if a number is between 1 and 2, these are not definite number. If I say the number is 1 or 2, this is definite. But if I say the number is between 1 and 2, there can be series of numbers within 1 and 2. Then we call this type of number continuous number. So anytime you want to make a prediction that you are getting value, for instance, price of a house now, it can be $300.5, it can be $500, it can be $500.5. That is continuous prediction. And you are going to be using regression model to do that type of machine learning prediction. So example is the price of house. Of course, we have our popular linear regression. It's different from logistic regression. There are two different things. If you have
What's between the logistic and the linear regression?
actually, I would have loved to go deep down. I will explain it now, but I don't want to go deep down into them now because we are still going to deal with them extensively. But I will just explain. The logistic regression, most of the time, we use it if you want to output two values, two class, okay, binary class. It is under classification problem. You want to have an output that is just one or two, A or B. Then we use logistic regression. But for linear regression, right? For linear regression, it is used for continuous value that can be between number line 1 and 2. We will still talk about them more when we are dealing with each of them separately. But we are just giving a general overview of the machine learning model today. So let's move on with what we call unsupervised learning, which is obviously the opposite of supervised learning. In the case of unsupervised learning, as I've explained supervised learning, there will be a mapping. If I say mapping, it means that the input S that you are giving is going to be used to produce the output Y. But in the case of supervised learning, the output Y is always given with the S if you are training your model. But in the case of unsupervised learning, the Y will not be given to it. You're only going to give it the input features, which are the characteristics that you want the model to learn from. So it's that model that will now make a prediction or an output based on the input you gave to it. There's a particular example here. For instance, now, we have one problem type that we can use unsupervised learning to solve, clustering. The meaning of clustering in a layman word, we can say grouping. For instance, if I want to group people from Nigeria together, there will be some attributes in them. Nigerians, they are dark, they have, we Nigerians, I don't know attributes, but Nigerians, we have some attributes. Some of us have beer. No, don't let us use that one. Some attributes that are peculiar to Nigerians. Nigerians are dark, Nigerians have white teeth, they are handsome. I'm just assuming. Then the Ghanaian. Wait, so I've listed 3 attributes that you will use to categorize or group Nigerians together now. Then the case of Ghanaian, their English is like they are faking it to make it.
Yes.
We've made
I'm joking anyway. Their English is very unique to them. It's different from our own, adulterated English language. Sorry. But the Ghanaian English is unique. They have the way they speak their English is different from the Nigerians, and so on. Most of their girls are beautiful, and so on and so forth. Now, these attributes will also help me to group the Ghanaian in a set. It's like when you have a set of GSS1. Do you know GSS1, Junior Secondary School? Or a set of Primary 1, Primary 2. It's like you identify what is common to the Primary 1. Most of them, they will be of the same age range. Most of them, they will be of the same height. Primary 2, most of them will be of the same age range and so on. So in unsupervised learning, what we are only giving are the attributes, they are the characteristics, they are the input features. And this input feature is going to check the commonalities, as in something that is common to them, to group them together. So that kind of grouping is done using a technique called clustering, for instance. In clustering, the model will try to group data together based on the similarity that I've just explained now. And it is a type of unsupervised machine learning because I have not given it that, I'm not giving that model that if this guy is as tall as this, then the guy is a Nigerian. I've not given it Y. I've only given it S. Then it's going to group them together. Those that are in the same group, put them in a circle, put Ghanaian in a circle, and so on and so forth. Then the other one that we use is dimensionality reduction. It's also a form of unsupervised learning. Okay, let me explain that this way. If I'm building a model, I have input feature that we have been using since morning. If I want to predict the price of a house, for instance, we can talk of the location, the size, the number of rooms, and so on and so forth. And the color of the house. Let's say, for instance, we have a ridiculous input feature, color of the house. How does the color of the house influence the price of the house? It doesn't make sense. It doesn't, right? Okay. But let's assume that we put all of this in the model to make prediction. If you put all of this input feature in the model, it is not all of them that will have enough relevance, that is relevance, to give us the output. So when you talk of dimensionality reduction, is a way to reduce the input feature. The model is going to reduce it automatically to only the most important input feature that is relevant, that is most relevant. Let's say that the input feature that you pass to it, there are 4: the color of the house, the number of rooms, the location, the size. There are 4. But we know that maybe it is only 2 that is very relevant to tell us the price of the house, assuming. Then the model will reduce it from 4 to 2. That is dimensionality reduction. It's a way that the model used to reduce the number of input feature to only the relevant one that it needs for its prediction. You are also not giving it Y. No, you are putting all the input feature there, then it's going to cut it down to the most relevant input feature that the weight is very important. Do we understand? Any comments, anything that is not clear, and so on?
How the machine know which ones are relevant and which ones are not relevant?
How can it know? That is the power of machine learning. We have a technique to implement that dimensionality reduction. We have a technique, we call it PCA, Principal Component Analysis. We have it, we can implement it as we learn. So it is the work, that is why it's called machine learning. It's going to figure out, based on all these input features I'm giving, which one did I think? There is what we call correlation matrix. I don't want to start. That's data science, basically. The correlation matrix is used to, assess the correlation or how relevant a particular feature is to a particular output you are predicting based on a particular score. The one that has high correlation will be very close to 1. The one that has low correlation will be closer to 0. So the machine is going to do that calculation behind the scene and keep only the one that is closer to 1. So we use a technique called PCA to implement dimensionality reduction. We can explore that if we start implementation. Small. If you are bored, let me know. You might be bored. I'm the only one speaking, and you are just listening. Why will you be listening only? If you are bored, let me know. No response.
So this unsupervised learning, this thing is just like just a method of writing, like the coding. I want to talk about the coding. The coding is just like you write it straightforward, but there are 2 methods of problem that it can solve.
There might be more than this. I don't want to overwhelm you.
Okay.
I don't want to overwhelm you. I'm trying to make it as basic as possible. We have K-means clustering, we have hierarchical clustering, and so on. They are more than this, I know. But I want to keep it as simple as possible. And this dimensionality reduction, we use PCA for that. So let's assume now that you have some data sets of your classmates that you want to put into different groups. And you ask from them their first degree, their second degree, the course they like. Let me say you want to put them in maybe different group or clubs, for instance. The data set you have gotten, you have your data set on the table. Then you can put this data set, you can use what we call clustering, K-means clustering, put all these data sets, you don't label it, you don't give it Y. You only have the S. Each of the input feature for, let me say my name is Ayo, for instance. Then I have Ayo. I have X1, I have S2, I have S3. I don't have my Y. Let's say Ayo, I am tall, I am dark, I am tall, I am dark, I am slim, for instance. These are all my features. Then you can take these features and put it as input inside the clustering, algorithm. So with this feature, then if you have another person, Dele or any of you, your attributes also as the input feature, then the machine will classify them together based on their similarities of this input feature only, without the Y. Do we understand?
Yes.
Without the Y, that is unsupervised learning, and that's what clustering does. So I think we should be done with learning. A lot of words here. Reinforcement learning is different from everything we have been talking about. It is a kind of algorithm that works on maximizing your reward function. The technical term is too much. Let me practicalize it with this. When a model is built, for instance, when a robot is built, if I build a robot now, and I want this robot to perform a particular action. Let me say I want the robot to identify obstacle. Okay, that this is an obstacle, and the robot should be able to identify and avoid that obstacle. Now, when the robot is moving, initially it might be stumbling on the obstacle. Initially, it's your robot. Anytime you build a robot, your robot is like a toddler, an infant that doesn't know anything. Okay, so this robot, as it encounters the obstacle and is what do you call it now? It encounters the obstacle and is getting knocked down by the obstacle, for instance. As it does that, there is what we call reward function that you as a machine learning engineer have built in the robot. The meaning of that reward function is that if the robot encounters obstacle that you don't want it to encounter, for instance, you are going to be giving it a negative reward, or you remove the reward you give to that robot is going to be reduced. So when you do that the first time, next time that your robot is doing the same action, your robot will know that if I do this thing, it's like a child. If I do this thing, then my reward is going to be removed. Then the robot will know that, I should avoid this obstacle. It's like when a child that is just trying to walk, the same picture is what we have for reinforcement learning. Reinforcement learning is a type of algorithm that works based on environment. Your agent or the model, we call it agent, we call it model. That, for instance, the robot that I'm using, when you want it to avoid obstacle, anytime it encounters that obstacle, you will have built you have written a reward function that will be removing its reward if it stumbles on that obstacle, so that it will not go back to that obstacle in future. A young child now that knows that anytime he or she does something, maybe the child took something you don't want it to take, then you beat the child, for instance. That's like a reward function. You beat that baby, then when the child sees that kind of thing, he or she will remember that I'm going to be beaten if I take this thing again. So it's a form of beating, and by that beating, you are training. That's the way reinforcement learning will work. You are training the model like that by adjusting its actions as you remove the reward or you add to the reward. But when the model does what you want it to do, you increase the reward function. Like you are giving the child sweets. You are giving it presents. You are what was that English again? Anyway.
You're bragging.
No, you are encouraging. No, you are what's the English? Motivating. No, it's not motivating. But anyway, do you get it now? Yeah. Reinforcement learning is more advanced. Yeah. It's not something that someone that is not really interested in machine learning will want to go to. So I'm not going to be talking about reinforcement learning in the technical term at all. So we just stick to the most important one: supervised and unsupervised learning. Fair enough. So that's the English that is written here. So application of machine learning, just as all of you know. All right. Okay, anyway,
Healthcare.
we have healthcare, of course, they use it for drug discovery.
Yeah.
It can give personalized treatment. For instance, every individual now, instead of the doctor diagnosing them himself or herself, when you have machine learning model that will take your input feature, your data set, then it's going to tell you, okay, based on this data set, this is the type of treatment that will be administered to you and so on and so forth. It's very powerful. Then we have finances. We use it for anomaly detection, fraud detection, and then anomaly detection is also another type of unsupervised learning, but we're not going to be talking about that. We have transportation, of course. We have the self-driving car that can identify obstacle, objects, and so on. That one uses what we call computer vision, which I've worked on before. Then we have your popular chatbots, your ChatGPT is with you there, and so on and so forth. Then marketing, of course, we have a recommender system. I'm not going to talk about recommender system here too. I don't want to bore you. So let's just keep it simple. So I think I will want you to keep abreast with this social media platform, especially the blog. I want you to check out the blog, give your criticism of the blog so that I will improve ahead of next time that I'm going to be writing the blog. From next time, it's going to be more technical. It's going to be more technical. I have to do some mathematics. Don't worry, it's not the hard maths, simple maths. I'll do the math, I'll do the implementation, and you too, you will also implement it on your own. If you are ready to learn, I will definitely support you. And I will also give you resources you will need to go through it. Because of course, I'm developing some content. Subsequently, we will be talking on this platform. Everything. LinkedIn, Twitter, and so on. And I think we are done. We should be done.